Okay. Now, I am going to do one small thing that will help us understand further. When we go back to this, let us deal with translatory motion separately and rotary motion separately. Okay. What I am going to describe right now is the rotary motion. In order to understand that, what I will do is I will move this reference frame to this point, okay, and describe only the rotation. Okay. This is just to understand what happens to this vector RAB. Okay. Think of it like this, this is the B that we are talking about, and let us say this has rotated to become something like this. Okay. So, point A was here, it has become, this is the final configuration that we are looking at. Okay. What is basically happening is, in this rotational motion, this vector is turning to rotating about a particular point. Okay. Now, if I have to understand this, let us just go with something that represents this vector as it moves. Okay. So, let us say I have a point here which is A. Remember, as A moves, this line also moves. Supposing the point A comes over here, this also comes over here. If this is B, what is this? This is R of A with respect to B, R of A with respect to B after it has moved, alright. So, we will represent this by a vector ER which is along this line RAB, RA with respect to B, and another which is perpendicular to this, which I am going to call as E theta. Okay. These two are the unit vectors I am using. Why am I using this unit vector? Very simple. Supposing it rotates this way and reaches this particular point, let us say this is a new location A prime, A prime. Remember, ER is now rotated this way and E theta also has rotated like this. Let us say it has gone through a rotation of this sort. Okay. How do I represent RAB? It is nothing but R of A with respect to B is nothing but, let us say we will take small r. So, this is a vector, this is a scalar times the direction is ER, or AB, which is the position vector of A with respect to B, can be now written as some value here R, which is nothing but the magnitude of the distance between them times ER. Okay. Now, I have a representation. The beauty of this representation is, remember, ER is now rotating. Okay. So, if I find the time derivative of this rotation of ER and E theta, I will be able to solve this problem. Okay. Given this, how do I find out R dot of A with respect to B? Most of what we are going to talk about will involve this R dot of A with respect to B. Okay. Simple, we will use the simple derivative. The time derivative of this is what is going to give us the derivative of this, time derivative of this, but this is a product of two quantities which are changing with time. Is R changing with time? Not really. ER is changing with time? The answer is yes. Yes. So, this will be R times let me just make it general and then use the concept of the rigid body. So, I have just taken the derivative, partial derivatives. If you look at this, I have taken the derivative parts. R dot is 0. Why is R dot 0? Because it is a rigid body, the distance does not change, which means this is equal to 0. We have R times ER dot. I know R that I have specified, but what is ER dot? How do I find out ER dot? That is the next question we will ask and then find out what is happening here. From an understanding of how it is changing here, I should be able to find out what is ER dot. Okay. So, let me just use a separate figure over here in order to understand this. Let us say this is at a time t, and at time t plus delta t I will draw one more configuration. Okay. So, this is the vector that you have R of A B, this is ER. Okay. Once it has rotated by let us say a delta theta, okay, which is small, it will reach this particular point. Let us say this is A prime as we have discussed earlier. You find that ER is now shifted in its direction. Okay, let me just put it as ER prime so that we understand this. All right. If I superimpose the directions, I will find that this direction is like this. Do you agree with me? And what is the angle between these two? It is delta theta, right. Let me just zoom this in. I have ER, I have ER prime, just to give you an idea. The angle that it has gone through is delta theta. If I have to find out ER prime, ER prime is nothing but ER plus a vector that joins this. You agree with me? ER plus a vector that joins this. Okay, so let me just take this vector as T. Okay. Do I know the length of this vector? Since this is a small rotation and this length does not change, the length of this vector T is R times delta theta, right. So, its magnitude is R times delta theta. You agree with me? Where R is the magnitude of R A with respect to B. How about direction? What is the angle between these two? What is the angle between ER and T? It is tangential, or in other words there is a 90-degree angle, which means the unit vector along this T should be nothing but, as we have mentioned over here, ER and 90 degree is E theta, which means this will be R times delta theta times E theta. Do you agree with me? Is this clear? Is this clear? So, r times delta theta E theta is the rotation it has undergone over a time delta t. So, over a time delta t, this is what has happened to what? To ER. Okay. So, let me just write that down here. ER prime is nothing but ER plus r delta theta E theta, right. What we are interested in is how it has changed, or in other words ER dot is what we are looking at. If this is ER and this is ER prime, which is a change that has occurred over delta t, then ER dot is nothing but limit as delta t tends to 0, ER prime minus ER divided by delta t. Is this okay? This is the changed vector, this is the original vector divided by delta t. Okay. What is ER prime equal to? It is nothing but ER plus r delta E theta, or in other words ER prime minus ER is equal to r delta theta E theta. So, what we get here is r delta theta delta t E theta. Okay. Let me put a limit over here. This is okay. What is limit as delta theta or delta t tending to 0? Delta theta by delta t, it is theta dot. So, I have r times theta dot E theta as ER dot. So, let me go back to this and write this to be equal to r times, we have one more r over there, am I right? What is this distance equal to? Is it r? Let us look at this t. What is the length of this? This is ER. What is the length of this? What is the length of a unit vector? 1. So, when I took this r is actually equal to 1, right, and therefore, in this let me just remove r here, so that we get this r times theta dot E theta. Is this clear? Why is it so? Because ER dot, rate of change of the vector ER, happens to be equal to theta dot E theta. So, we find that this is the way it has moved. So, if I zoom in, I have this as ER. What is the length of this particular vector? It is equal to 1, right. It has now changed its direction to something like this. Let me call this as ER prime. If I take this as let us say alpha vector, then I can write ER prime vector is equal to ER vector plus alpha vector, right. ER plus alpha is equal to ER prime. Okay. What is the length of ER prime? That is also equal to 1. What is this angle? This is delta theta, and this has occurred over a time delta t, all right. This implies that ER prime minus ER is equal to alpha. Let us now focus on alpha, alright. What is the magnitude of alpha? Well, that is not very difficult, since this radius is 1 and it has gone through a delta theta, the magnitude of this should be 1 times delta theta, okay, which is delta theta. What is the direction of this? Remember, this is along the tangential direction to the sweep that occurs, okay, and therefore this is perpendicular to ER. If you go back to this, what is the direction vector that is perpendicular to ER? That is the unit vector E theta, okay, and therefore alpha can now be written as delta theta times E theta, okay. And what is the rate of change of this vector ER? It is nothing but limit as delta t tends to 0, whatever change has occurred to ER divided by delta t. The change that has occurred is ER prime minus ER, which is nothing but alpha, but alpha is equal to delta theta minus E theta, and therefore this is delta theta divided by delta t times E theta, okay. So as limit tends delta t tends to 0, this becomes theta dot E theta, okay. Therefore if I go back to this, what is the derivative of R A with respect to B? It is equal to R times ER dot, but ER dot is equal to theta dot E theta. If I substitute, I get R theta dot E theta, okay. Just to get an idea, R times the theta dot, and is the magnitude of the velocity, and the acceleration and the direction is E theta. That is very clear here. This is the direction along which the velocity due to angular motion occurs, and R times theta dot is the magnitude of the velocity.